What's up everybody, I'm Uzi. I'm back with another networking video, and today I'm talking about VLANs. A VLAN is a virtual local area network, and it creates logical divisions in a physical network. What I mean by logical divisions is that it uses software rules, not physical cables, to separate these networks. It allows multiple networks to exist on one switch. You can kind of think of it like a classroom. You have a classroom of 30 students, and the teacher divides the classroom into 3 groups for a project or something. Everyone's in the same classroom, but you're in 3 different groups, and you only talk to people within your group. Each VLAN has its own broadcast domain where broadcast traffic stays within. So by isolating this network traffic, it reduces network congestion, it improves security, and it allows the flexibility of device grouping. Altogether, this helps make network management so much easier. So how VLANs work is that they tag Ethernet frames with VLAN IDs. And remember, frames are the type of data that's transferred at layer 2. So switches take these IDs, they determine which VLAN the data is for, and they send it. For example, in this diagram, you have one switch which manages 3 VLANs. Each VLAN has 2 PCs. Despite them all being connected to one switch, the devices in these different VLANs can't communicate unless they're routed. Here's another example of a basic VLAN setup. In many real-life situations, you'll have VLANs set up to space out network flow between different departments. For example, you have VLAN 10 for marketing and now VLAN 20 for sales. Right here is a trunk port leading to another router or another switch. And if you don't know what those are, we'll get into that right now. So what we're going to talk about now is VLAN routing. There's 2 ways to route VLANs. You can use a layer 2 switch or a layer 3 switch. Using a layer 2 switch, you're going to follow router on a stick. Using layer 3, you'll follow the switch virtual interface. So router on a stick. This is where you have a layer 2 switch which connects to a router via a trunk port. This is called VLAN trunking. This is a method used in computer networking to allow multiple VLANs to share the same link between switches, routers, or a switch and a router. It helps to enable communication between the VLANs, it reduces the amount of physical connections needed, and it improves the overall scalability and flexibility of the network. So after this trunk port is set up, you have sub-interfaces that need to be configured on the router. Each of these sub-interfaces are configured to different VLANs. These sub-interfaces get an IP address, which is also the default gateway for the VLAN. This is what allows the inter-VLAN communication. And next we have a switch virtual interface, SVI. With the switch virtual interface, you don't need a router or a trunk port. All you need is a layer 3 switch. This switch performs the routing internally. In this system, you create the VLAN and then you assign it with a switch virtual interface. And after this is done, each VLAN will have one SVI and one IP address, which is the default gateway. These are much easier to configure and more optimal than a router on a stick. Now for my favorite part, we're going to go back in Packet Tracer. I'm going to show you guys how to route VLANs using a router on a stick and a SVI. Alright you guys, we're in Packet Tracer, and now what I'm going to do is configure a router on a stick. I'll start by getting a router, attaching it to a layer 2 switch, and then attach that layer 2 switch to 4 PCs, 2 in VLAN 10 and 2 in VLAN 20. There's router, layer 2 switch, 2 PCs here, and 2 PCs here. I connected all the devices with a copper straight through cable, and I labeled the interfaces to help you guys follow. Now I'm going to separate the VLANs. This side will be VLAN 10, and this side will be VLAN 20. This will be the 192.168.10.0 network, and this will be the 192.168.20.0 network. The default gateway for VLAN 10 will be 10.1, and the default gateway for VLAN 20 will be 20.1. Here's some colorful circles to help you visualize, and now we're ready to get started. The first thing to do is to run no shutdown on the router to get these red arrows turning green. Click on the router, go to the CLI, go to configure terminal, interface gigabit 0/0/0, and now run no shutdown. Now we're going to go to the switch and create the VLANs. So click the switch, configure terminal, and now I'm going to type in VLAN, and this can be any number between 1 and 4094, but for the purpose of this video, I'm just going to choose VLAN 10. Now we're in the interface configuration mode for the VLAN. I'm going to enter name VLAN 10, and my name is going to be VLAN 10 in all caps. Then I'm going to exit. Then I'm going to repeat this process for VLAN 20. Name VLAN 20, exit. Now what I'm going to do now is stay in config mode, and I'm going to go into these interfaces 2 through 5 and configure the VLANs. So I'll start with the 0/2 interface. I'm going to type in the command switchport mode access, and then type in switchport access VLAN 10. Then I'm going to exit and repeat these commands for the next interface 0/3. Switchport mode access, switchport access VLAN 10. Exit again. Now I'm going into the 0/4 interface, switchport mode access, and switchport access VLAN 20. Because remember, this interface 0/4 is connected to this VLAN, VLAN 20. Now I'm going to exit out of that interface, go into the last interface 0/5, switchport mode access, switchport access VLAN 20. Now we've assigned ports to the VLANs. Now I'm going to go back to the router, and once I'm in the router, I'm going to create the sub interfaces now. So I'm going to go to router config mode, enable, configure terminal. Now I'm going to type in interface gigabitethernet 0/0/0, but I'm going to put a .10 at the end of it to indicate that this is a sub interface for VLAN 10. As you can see, the state changed to up. Now I'm in the sub interface configuration. Here I'm going to type in this command, encapsulation.1q10. And just so you guys know, I'm going to put all these commands in the description for this video. There's a lot of new commands to follow. So I'm going to enter this. Now I'm going to type in IP address. This command is going to be IP address followed by the default gateway IP followed by the subnet mask. To be specific, it's the default gateway for the VLAN subinterface you're configuring. So for this case, it's going to be this default gateway, 192.168.10.1. And it's a /24. That means the subnet mask is 255.255.255.0. So I'm going to enter that. Exit now. Now I'm going to type in the same interface command, but I'm going to add .20 instead of .10. This is going to be the subinterface for the VLAN 20. Now we're going to put encapsulation.1q20, and we're going to do IP address with this default gateway, 192.168.20.1, and the subnet mask. Enter that. And now we're going back to the switch. Now we're going to configure our trunk port, and our trunk port is going to be this interface that connects the switch to the router. In a router on a stick, this is always the trunk port. Click the switch, enable, configure terminal. Now I'm going to go into this interface, fastethernet 0/1. Now I'm going to type in this command, switchport mode trunk. Now I'm going to type in switchport trunk allowed VLAN 10,20. Didn't like that. Try it with no space and that worked. So that should be it for configuring the router and the switch for the router on a stick. If there's something I missed, we'll soon find out. Now what we have to do is configure IP addresses and default gateways on all our end devices. Start with PC0, desktop, IP. So we'll give it .10.2 for the IP address. Subnet mask fills in. Default gateway will be 192.168.10.1. We can exit out of there. This PC, same deal. We'll do 10.3. The default gateway is 10.1. Exit out of there. Now this VLAN PC, desktop, IP config, we'll do 20.2. Default gateway 20.1. And the last PC, 20.3. And 20.1 for the default gateway. What I want to do now is run some ping tests and see if I can ping from this VLAN to this VLAN. I'm going to go to the command prompt and let's see if we did it. Request failed at first, try it again immediately after, and the ping worked. Another command, if you want to do some troubleshooting, you can go to your switch and type in show interfaces trunk. This will show you some good info. As you can see here, this is the trunk port, FA0/1, VLANs allowed 10 and 20. You can also run show VLAN brief. Now you can see all the VLAN information that you have configured. So that's a router on a stick. Next, we'll go over an SVI, switch virtual interface. So now we're going to configure using a switch virtual interface. So now I'm going to grab one of these layer 3 switches. And I'm going to grab 3 PCs. Now I'm going to connect these. And now I'm going to label out the IP structure I want for this design. So this is our setup for switch virtual interface routing. Similar to last time, we have VLAN 10, VLAN 20, and VLAN 30. Same number of networks, 192.168.10.0, .20.0, and then on the bottom .30.0. And the default gateways end with .1. For this example, we're doing 3 VLANs. Most of our modern layer 3 switches can support up to 4,000 VLANs. The first thing we'll do is go into the switch and create and name the VLAN. One important step is to name the switch before you do any of this. So type enable, then configure terminal. I'll type in hostname switch1 to name the switch, and I'll create the VLAN by typing in VLAN 10. Now to create the VLAN's name, I'll type in name VLAN 10. Now I'll exit and repeat for the next 2 VLANs. VLAN 20, name VLAN 20, VLAN 30, name VLAN 30. Now I'm going to assign ports to the VLANs. So I'll go back to configure mode and I'll type in interface fastethernet 0/1 because that's the interface that connects to VLAN 10. We go switch port mode access, switch port access VLAN 10. Now we repeat this for interface 2 and for interface 3. So we will go into interface 0/2, switch port mode access, switch port access VLAN 20, exit out and repeat. Fastethernet 0/3, switch port mode access, VLAN 30. Now what I'm going to do is configure the IP addresses on the end devices. PC0, give them IP.10.2, /24 subnet mask, and 10.1 is the default gateway. Now VLAN 20 PC, .20.2, subnet, .20.1. And the last one, 30.2 and 30.1 default. Now the last thing to do is to configure each VLAN with the IP address. So we go back to the switch, configure terminal, go to interface VLAN 10, and same command as before. It's IP address followed by the default gateway IP address followed by the subnet mask. IP address, .10.1, and the subnet mask. And I'm going to exit and repeat this 2 more times. Go to interface VLAN 20, I'll just copy that IP. I'll change the 10 to a 20, enter, exit and go to VLAN 30. I'll paste again and change the 10 to a 30, enter that. And now I'm going to go exit and type in this command, IP routing. I'm going to end that, and now the switch virtual interface should be configured. So now we're going to see if the ping tests work. I'll go to PC0, command prompt. I'll ping 192.168.20.1. Times out for a second, usually on the first try, and I think it went through. I'll try it again. And now we're getting it. Now see if we can ping 30.2, which was the PC in VLAN 30. Pinging. Timed out for a second, but then it keeps going and then replies. I'll try again just to get a faster one. And there we go, we can ping both of them. And there you can see a switch virtual interface. You don't need a router, you don't need to make trunk ports, and I personally think it's way more efficient. That being said, there's going to be certain situations where you have no choice and you have to know both. So that's it for the packet tracer examples. Hope you guys understood them, and let me know if you have questions. And that's it for this video, you guys. Thank you for watching. Today we went over routing VLANs using router on a stick and a SVI. Thank you again. I'll see you in the next video.